Okay, this is lesson 36, right triangle congruence theorem. So you know so far we have already learned side, 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 angle, side, angle, side, angle, and angle, angle, side, right? These are all the triangle congruences that we've talked about so far. Well, the one that we're going to learn today is specific to right triangles. These were any triangles, okay? So that's what we're learning today. We've got 4 different theorems that we're covering, and they're in your theorems chart. There's leg angle, which is abbreviated LA. There's hypotenuse angle, abbreviated HA. Leg, which is abbreviated LL. And then hypotenuse leg, which is abbreviated HL. Now you'll notice the diagrams over to the right of each theorem. You notice right here, we have a leg and we have an angle. We have a leg and we have an angle. That's why it's called leg angle. And it might be the other angle. See here? Leg, angle, leg, angle. And remember, these only have to do with what kind of triangles? Right triangles. Very good. Now the second theorem, 36-2, is hypotenuse angle. So as you can see, we have the hypotenuse and an angle congruent to hypotenuse and an angle. Pretty self-explanatory, right? Look at theorem 36-3, leg. Well, leg of one congruent to leg of another. And then last but not least, we have hypotenuse leg. So the hypotenuse and the leg of one triangle congruent to the hypotenuse and the leg of another triangle. And again, these only have to do with what kind of triangle? Thank you. Okay, so let's practice a few, and then you will do some on your own. So, notice here, we have leg and angle. So, which one of these do you think is the triangle congruence of these two? Yep, LA. Very good. Now look over here. We have the leg and we have another leg. Any idea? LL. Very good. LL, which stands for leg. Okay, down here we have the leg and we have the hypotenuse. HL, hypotenuse leg. Excellent. And then lastly over here, notice how they want us to be able to see or identify the vertical angles as congruent. So we have hypotenuse and we have an angle. Which 2 letters should I use for this one? HA, hypotenuse angle. Perfect. Okay, I would like you to flip to this page and label those 1 through 10 with either LL, LA, HL, or HA. All right, Logan, what did you get for number 1?
LA.
Muy bien. LA. Double check that that's what you put. Number 2, Kellen?
LL.
Excellent. Leg, leg. I agree. Harper, number 3.
Leg angle.
Leg angle, LA. Love it. Gabby, number 4.
Would it be leg angle?
Perfect. Leg angle. You got it. Did y'all happen to see that they wanted you to know that this side was congruent to itself? Therefore, it's leg angle. Okay, back at Logan.
I got HA.
HA for number 5. Do y'all agree? Are you sure it's the hypotenuse? See, look. Here's the A, the angle, right? Because they're vertical. But this right here is the leg. The hypotenuse would be right here, across from the right angle. So it's not the hypotenuse that they gave us. They gave us a leg and an angle. So number 5 should be LA. Do y'all see what I'm talking about? Okay, good. All right, Kellen, number 6. LL. Let me look. That's not what I got. Okay. Do you see this right here? The right angle. Across from that is the hypotenuse. So this right here is the hypotenuse. And then they wanted you to know that this side was congruent to itself. So give it another shot.
Maybe hypotenuse angle, HA.
Not hypotenuse angle. See, look, I'll highlight it for you. We've got hypotenuse, hypotenuse, and then we have a leg and a leg. So it's actually hypotenuse leg, HL. Because, see, they didn't give us any other angle other than the right angle, but that one doesn't count when it comes to the abbreviations. It has to be one of the others, not the right angle. Okay, I think we left off at Harper.
Hypotenuse leg.
Hypotenuse leg. Because this is congruent to itself. So we have the hypotenuse and we have the leg. All right, Gabby, give number 8 a try.
LA.
Not LA, because I'm starting to see now what I need to work on with you guys. This right here is the hypotenuse. How do we know? How do we know how to distinguish between a hypotenuse and a leg?
Slanted.
Yes, it is slanted, although you won't always be able to tell.
The right angle.
Yes, you always need to find this guy and then go across. This guy, go across. That's the hypotenuse. These are the legs. These are the legs. But across from this is always the hypotenuse. So what's number 8? Hypotenuse angle. Hypotenuse angle, HA. All right, Logan, number 9?
Be HL.
HL. Yes. See, once again, y'all see this? That's the hypotenuse. And this one is the leg. All right, finish this off, Kellen. Number 10.
HL.
HL. Hypotenuse leg. Once again, here's the hypotenuse across from the right angle. Good job. All right, moving on to lesson 37, writing equations of parallel and perpendicular lines. This concept is not going anywhere. This will be on your SAT. This will be in college algebra. So this is not a concept you want to forget. Keep it fresh on your mind. The main takeaways for this lesson are parallel and perpendicular. Okay? When two lines are parallel, they use the same slope. Highlight that. Parallel, same slope. You may even want to write same slope. So, notice 1/2, 1/2. That's what makes those two lines parallel. They have the exact same slope. As opposed to perpendicular, which has -1 as the product of their slopes. Now that's just a fancy way of saying flip and change sign. Flip and change sign. So, look at these two. Do you see how the numbers are flipped and one's negative, one's positive? That's what I mean by flip and change the sign. Okay, so what does that look like? Whoa. Why is this upside down? Okay, that's very weird. Is it like that on your paper?
No.
That is odd. I wonder if I open this back up. This is, how can I rotate that? That's really bizarre. Okay, well. Sorry, I was trying to figure out maybe how to rotate it on my iPad. Okay, well, I'm going to try my best. Okay, so on your paper, you can see it correctly, right? It says find the slope of a line. Wait, is that what it says? It says find the slope of line A is what it should say. Find the slope. Okay, find the slope of line A. I'm not sure why it's inverted like that. That is so weird. I'm just glad it's not like that on your paper. Okay, find the slope of line A. So here's line A right here. And we're actually going to go up and over. So on your paper, I want you to start here, and I want you to go up 3 and over 1. I want you to highlight that. Go up 3 and over 1 from down here, from the 0, -3 dot. Find it on your, yep, and then go up 3 over 1. And then I want you to write down 3 and 1 like that on your paper, the way it should look. So the slope is 3. That's the answer to the first one, because it went up 3 over 1. So that's like this, but we just write it like that. All right, so if it says parallel, we use the same slope. So to find a slope of a line that's parallel to this line, we're going to say the slope is 3 because we want to use the same exact slope. But if they want us to find a perpendicular slope, then we're going to flip and change the sign. So look up here. You see how it was 3 over 1 positive? We're going to do 1 over 3 negative. 1 over 3 negative. That's the slope for a perpendicular line. Are y'all with me? Okay, I'm actually going to add a new page and do it like this because that's just confusing. Okay, so the next question asks me if this line, y equals 2x plus 4, and y equals -3 plus 2x, they want to know if that's parallel, perpendicular, or neither. Oops, that's not how you spell neither. All right. Do y'all have any ideas as to whether or not these two lines are parallel, perpendicular, or neither?
Parallel.
Parallel. How do you know that?
They're the same.
They're the same. They both have m equals 2. They just tried to confuse you by switching the -3 and the 2x. All right. Let me clear this. The next one says, are the lines y equals 2/3 x minus 1 and y equals 3/2 x parallel, perpendicular, or neither?
Perpendicular.
You're close. It looks perpendicular, but it's not. Do you know why?
Because they're not flipped or negative.
Well, they are flipped,
But they don't have a negative.
but they're both positive. I need one to be negative and one to be positive.
So it's neither.
Yeah, so it's neither. Do you see why, Gabby? All right, the next one says, oops. Find a line parallel to y equals x plus 2 and passes through 3, 8. All right. They said parallel. That means same slope. So, what's my slope in this line? What does my m equal? 1. There's an imaginary 1 right there. Here's my x. Here's my y. So, I got to find my b. Remember, y equals mx plus b? So, my y is 8. My m is 1. My x is 3 plus b. Did I lose anybody? Okay. 8 equals 1 times 3 is 3 plus b. Let's move that 3 to the other side by subtracting it. 8 minus 3 is 5. Okay, so I have my m and I have my b. What's my final answer?
Y equals 1x plus 5.
Oops. That line that I just found right here, that's parallel to this line. And it goes through this point right here. And I know these two lines are parallel because look, they both have the same slope. Okay, this time they're asking us for a perpendicular line. They want us to find a line perpendicular to y equals 2/3 x and goes through the point 2, 4. All right, any thoughts on what my m needs to be in order to be perpendicular?
-3/2.
Beautiful. -3/2. Here's my x, here's my y. What do I do next?
Plug you put x and y in.
So tell me what to write.
4 equals -3/2 times 2 plus b.
Perfect. Look how nice this is, guys. They cross cancel. I love it when that works out like that. 4 equals -3 plus b. How do I get that -3 over?
You add it.
You add it.
So you'd have b equals 7.
All right. I have my m. I have my b. I am ready to write my final answer. Go ahead, Gabby. Tell me what I should write for my final answer.
Y equals -3/2 x plus 7.
Ta-da! Questions? All right, moving on to the last lesson of the day. Lesson 38, which is perpendicular and angle bisectors of triangles. So this is in your theorems chart right here. It's basically saying that if you have a line that bisects, see this line right here? If you have a line that bisects an angle of a triangle, then it divides the opposite side proportionally to the other sides. So you see how there's a side here, 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 and here. It makes a proportion. So let me draw some tick marks in here to help you visualize. They're saying that PM and NM go together, and that PO and NO go together. See right here? They're proportionate. So let's work a problem together. Down here where it says, using the diagram at the right, find BC. They want us to find what this is. If AD is 15, I'm going to fill this in. They said AD 15, DC 8, AB 20, and they want us to find this. So, watch me. I'm going to do this over this equals this over this. Okay, 15 over 8 equals 20 over x. So 15 over 8 equals 20 over x. When you have a proportion like this, you cross multiply. So 15 times x is 15x. 20 times 8 is 160. Y'all still with me? Divide both sides by 15, and you get 10.6 repeating. Don't ask me why they give such ugly answers. I would prefer it be pretty so that way y'all don't second guess yourselves. Okay, do you feel comfortable giving these two a try by setting up proportions? So watch, this over this equals this over this. This over this equals this over this. And I would just use X for the question marks. Okay, give those a try. And it says round to 1 decimal place. So just like we did up above.
Want us to do both of the problems or just?
Both, please, if you feel comfortable. Did y'all get 5.6 for the first one?
Yep.
Good. .6. Double check, make sure y'all got them right. Okay, that's all for today. Now I want you guys to work these problems and see how you do.